everybody, and welcome to this video on the arithmetic series. In this video, we're having a look at another example. So in this example, we're given that Sn is equal to 8n squared minus 3, and we have to find the 10th term. Now, before that, let us establish the relationship between Sn and Tn. So if you think about S1, for example, you know that S1 is T1. Okay, that makes sense. S1 is T1 because the first sequence and the first term are the same thing. How would we define S2? S2 is T1 plus T2 by definition. And S3 is T1 plus T2 plus T3 by definition. S4 is T1 plus T2 plus T3 plus T4 by definition. Now what we would like to do is get something that's similar. So we want to write this in terms of S2 in terms of T. Now if we see the first one, we get that S1 is equal to T1. So here in the place of T1, I'm going to write S1. So S2 can also be written as S1 plus T2. And S3, similarly, this T1 plus T2 is the definition of S2. So S3 we can write as S2 plus T3. And S4, T1 plus T2 plus T3, this here is actually S3. And what we can then do is just add on the fourth term to get TS4. Now, if we make this statement general, we will get that Sn, any term, you can get it by taking the sum of the previous n minus 1 terms and then just adding the nth term. So generalizing this step over here. So what we can do is make Tn the subject. So Tn is equal to Sn minus 1. And this is quite an important expression. You should remember it and understand how to get it. It's how do we write our terms in terms of our series. Okay, so we're going to use that very formula. So we have T10 according to that formula is S10 minus S9. And why did we do that? Because we're given the expressions of S's, not T's, so we needed to write it. So S10, that is, we get that by substituting 10 in the place of n, so 10 squared minus 3, so that's 10, minus S9, we're going to substitute 9. Okay. Then typing this, oh well, this is 800 minus 3. So this here is 800 minus 3, which gives us 797. Minus, this is 8 times 81 minus 3. So 8 times 81 minus 3 is 645. And then subtracting that, we get our last term, which is, our 10th term, which is 152. So that is it. I hope that you have understood how to work with if you are first given the Sn and then you have to work back to T. So we are very used to working with T and moving forward to S. But here is an example where we are starting with Sn, the sum formula, and then we are trying to get the term, a specific term. Please watch our other videos for more information on sequences and series. Thank you for watching. Bye.